much, Everly. And of course, thank you very much to the organizers for inviting me to give this keynote lecture. I asked what this audience would want to hear, and I was very surprised to be told that you wanted to hear about what we were doing in the Memory, Aging, and Cognition Center over the last 10 years. So I apologize that the only animals we work with are consenting human beings. So if any of you feel that I'm not showing any Western blots, I'm not showing any, sort of cell cultures, I apologize now. Please blame the organizers. Now, I've given this audacious title, and Hatatip told me, wow, that sounds really dramatic. And I have to say, the reason why we put up this title is because we've just had the recent IRE, the research, Singapore's Research Direction 2030 Grand Challenge call, where they have identified that for healthy longevity, there are 3 pillars. There's physical health, there's social environmental innovations, and there's brain health. So this is why I'm saying it's an essential pillar. Many clever people who have advised on this think so I'm glad they've chose the brain. Because personally, I think it's obvious. There is no health without brain health. All of us here depend on our brains, not just to remember, but to be creative, to form friends, to form associations and relationships. Without our brains, we're just large rats. So brain health will be a pillar. These are the things that we've been asked to go and sort of look at in this grant call. And I hope that I will be able to illustrate how the Memory, Aging, and Cognition Center have, over the last decade or so, been able to contribute to many of these important issues. So, for those of you who are unfamiliar with the term, this is the World Health Organization's definition of brain health. It's written in this impenetrable World Health Organization bureaucratic speak, but suffice to say, it emphasizes it's our ability to function well despite aging and disease. And it's recognized that there are many determinants of brain health, not just aging or biology, but also social underpinnings. And that recognizing and being able to go and address these determinants will be what's driving not just the health of the brain itself, but also mental health. And it's very important for society. Nevertheless, as a clinician, I'm going to do what Brian usually hates me doing, which is to focus on diseases. Because, we are very morbid. We like diseases because they keep hospitals going and clinicians like me employed. So you're going to hear about some of the diseases that cause problems with brain health. But clearly, it's not just medical input that's going to solve brain health. There's going to be a lot of societal inputs as well. So what do we know about the diseases that cause brain health? This is a very large set of studies from the Global Burden of Disease study in the Lancet Neurology. And I'm sorry for the coloring, but basically the take-home message is that all around the world, regardless of which region you live in, brain health is determined by stroke and dementia. Effectively, cerebrovascular disease and Alzheimer's disease. Yes, of course, there are other diseases, but these are the biggest drivers. And we're not doing very well about brain health. Too much money has been spent on oncology. I can say that. And brain health suffers because we don't have the threshold to go and sort of make big advances. But we need this kind of funding to accelerate things. Also, much of brain health burden falls on low and middle income countries. In fact, in many developed countries, all these, although non-communicable diseases are increasing, the actual prevalence is falling because of better primary care. So for example, the incidence of dementia is falling across the developed world. It's really in the developing world that is going up. Same thing for stroke. Nevertheless, there's recognition that we really need to do something about brain health because it will affect the knowledge economy on which all the rest of human history will depend on. So what are we doing in Singapore? So Singapore is a very practical country, as you know. We realize that right now, we are spending less than most countries on health. But this happy state of affairs is not going to last much longer because our population is rapidly aging and the prevalence of all these chronic diseases is also accelerating. So the government recognizes that we're going to be facing more and more chronic disease. And again, because we are pragmatic, we realize that we don't have anything to offer the world apart from our brains. We don't have much resources. We don't have oil. We don't have tall, beautiful mountains with snowy peaks. We just have our people. And we have to be resilient. We have to retrain. We have to re-educate in order to cope with all the changes, as you know, are happening in the world. So government has realized that aging and brain health are very important. And a variety of initiatives have been acted upon and actually enacted in the last couple of years. And the most important ones include Healthier Singapore, where screening for chronic diseases, treatment for chronic diseases is now vastly subsidized and opened up. We are encouraging most of the population to have a primary healthcare practitioner who's going to look after your... Kevin, have you signed up for Healthier SG? Yes, good. Every sensible person has, because all of a sudden, the cost of my medications has just dropped, and I see the same person in the polyclinic now. So it's a dramatic change. But in addition to managing chronic diseases, it's now the emphasis on active aging and supporting seniors with needs in the community. And the government is putting a large amount of money into this. In addition, a lot more community support has been developed. And I'll emphasize two portions. One is Active SG. So did you know that the government provides gyms across Singapore? There are multiple, and now there are even more, all located conveniently, all using the same machines. So all you need is your smart card, which tells the machine where you've gotten to in your exercises, plug it in, and you carry on. On top of that, we have now renamed our senior care centers into what is called active aging centers. It's not just a rebranding. It's actually an emphasis on making sure that our aging population has ways of interacting, of having social activities, of having physical exercise, etc. And it's amazing. In clinic, I used to have a lot of problems telling people how to be active. But now they come and show me this little list from these active aging centers, and it's really a bit like a cruise ship, you know. Rumba at 10 a.m., they have Zumba dancing, they have line dancing, etc., and it fills up the week. And so that's quite remarkable. Now, what is the Memory Aging and Cognition Center's contribution to this? So I'm very grateful for the fact that we were started with a NUH startup grant with the help of Professor John Wong, who was our Dean and CEO, as well as Professor Eddie Koo, who was one of the first star investigators in Singapore and came to us from San Diego. Sadly, Eddie passed away this year, but his legacy is really reflected in not just the MACC, but many things around the world. And we have been funded consistently by the NMRC over this period. I totaled up the amount. It's a little more than what Immortal Dragons is offering, but I think it took us a hell of a lot more effort to go and get that money. But we are organized into 4 themes, a biomarker discovery theme, mainly focusing on blood biomarkers now. We have neuroimaging, which includes not just MRI, but PET, and also, importantly, retinal imaging, which I'll describe more, because we think that retinal imaging gives us a lot of information and is accessible. A clinical theme, mainly to do with clinical trials and observational studies, and a community-based epidemiology theme. We tried to keep busy, so this is a description of our major observational cohorts. And I think the one that we'll concentrate on is something we call the harmonization cohort, which is an Asian version of ADNI. I think those of you who work in the Alzheimer field will know that there is a very, very productive cohort called the Alzheimer's Disease Initiative. And what we have done is, rather than just focus on Alzheimer's disease, we have focused on the combination of cerebrovascular disease and neurodegeneration, particularly Alzheimer's disease, as a cause of cognitive impairment and dementia. One of the nice things about working in Singapore is that people can't escape unless they try very hard. So we have pretty good retention rates. And in fact, we have completed 5-year follow-up on all our patients. And we are now engaging in long-term follow-up. So if we are successful in getting the next tranche of funding, we will have a median follow-up of 16 years, a maximum follow-up of 20 years on our subjects. And what do we do with them? Well, we have a very strong set of platforms. In particular, we have the clinical and neuropsychological assessments, but we also do blood biomarkers, including genetics, neuroimaging, as I said, plus retinal and cardiac imaging, because we know that the brain is not isolated. It has strong connections with the heart and vascular disease. It also can be visualized using retinal imaging. For those of you who are interested, in order to mark our 10th anniversary, which we wanted to go and do a summary of all that we accomplished in harmonization, but our 10th anniversary fell during COVID, so we postponed this, and this is the recent paper we published showing that the methods that we use and the research sequence. These are our subjects. We have a multiracial view of a cohort from Singapore, which is old, elderly. We have done a lot of investigations. And I think the most important thing, of course, is that we've been productive. And hopefully productive in a more sophisticated way as time has gone by. So we've gone from single cohort studies to discovery and validation studies with large cohorts. We've gone from having single biomarkers to multiple biomarkers, single modalities to multiple modalities. And I think this is the strength of cohort studies like this. So I'm now going to review a few of the highlights of our research contributions. And I think the first highlight is something that was previously invisible, except to neuropathologists. And these are lesions called microinfarcts in the brain. So you can see them on histological sections as small cystic or gliotic lesions. And it turns out for neuropathological studies that these microinfarcts are really the strongest correlate of cognitive impairment and dementia. And they're found not just in vascular dementia, but also in Alzheimer's disease and in non-demented elderly. As I said, they're previously invisible. So this is a very seminal piece of work from the famous nun study in the US, where elderly nuns donated their brains to the neuropathologists. And what pathologists were able to show was that there was an additive effect of microinfarcts on top of neurodegenerative pathology. So if you had Alzheimer's disease pathology, having microinfarcts made you express disease sooner. And that's fine. But of course, most of us don't want to donate our brains to the neuropathologists. So it was amazing when colleagues from Utrecht showed that you could detect the larger cortical microinfarcts using MRI scans. So you can see them as tiny little bites out of the cortical rim. We very quickly took this into our cohort and showed that it was possible to measure these lesions in living people. And that importantly, we could show that it affected higher cognitive function, including language as well as visual construction. Moreover, we could show that it was highly associated with vascular dementia. We then moved to looking at our community-based cohorts, and we were also able to show that there was about a 6% prevalence of microinfarcts in this relatively healthy population. Nevertheless, what this enabled us to do, whoops, oh dear, you can't go back. Okay, can you go back one? Okay. It was enabled us to show what are the risk factors for microinfarcts, and not surprisingly, they include cardiovascular factors, and it was strongly related to many other MRI markers of cerebrovascular disease. These microinfarcts are important because they not only associate with cognitive impairment cross-sectionally, but they also predict for cognitive impairment longitudinally. And I have to say that I thank my colleague, Dr. Saima Hilal, who's now an assistant professor in the School of Public Health, for doing much of this work. We've done other neuroimaging studies, and this is work led by Helen Cho, who is the director of the MRI Imaging Center at NUS, to look for earlier markers of cerebrovascular dysfunction. So we've looked at what is called free water, and we can find that it is very well correlated with cognitive function, and it appears earlier than white matter disease and all the other later markers of cerebrovascular disease. And I'm extremely grateful to be working with people who are smarter than me, who have developed a lot of neuroimaging studies and have shown that there are not only sort of new markers, but also these markers interact with the connectome. In fact, Thomas Yeo, who also works at the imaging center, has fulfilled a lifelong dream for me. Because whilst as a clinician, I feel very happy to publish the New England Journal and Lancet, etc. Thomas has actually got us a publication in Nature. So that means that I can now happily retire. Oh, maybe not. I don't have a publication in Science yet. So moving on to the retina. I told you that we focus on this because actually you can see into the brain through the eye, because the eye has a lot of small vessels, and these small vessels are very similar to the vessels you have in your brain. In fact, they come from the same embryological source. Not only can you visualize vessels, you can also visualize the retina, which is the most accessible part of the central nervous system. Moreover, the machines that are able to do this are found on if you were in England, you say every high street, in America, every main street, but in Singapore, they're available in every shopping center, because every optician has these kinds of machines. You will not find MRI scans or CT scans in every shopping center, but you will have retinal cameras and OCTs. So this is a very accessible way of assessing not just the health of the eye, but also brain health. So, as I said, we can measure retinal cells, we can measure changes to these retinal cells, and we can look at the microcirculation. All very important predictors of brain function by looking at retinal vascular imaging and optical coherence tomography. So this work was done in collaboration with Professor Wong Tian Yin, who's Singapore's most prominent clinician scientist, and now is the dean of the medical school at Tsinghua. So with him and Professor Carol Cheong, we started this work on our harmonization cohort to show that there was microvascular alteration in the retina of patients with Alzheimer's disease. Just to say that we can measure a lot of things, but they all turn out to be positive in Alzheimer's disease. People with Alzheimer's have narrower, sparser, and more tortuous vessels. Furthermore, as I said, we could look at the thickness of the retina. So this is, I always think it's amazing that you can see all these retinal layers. But importantly, we can see that there are changes in Alzheimer's disease. So you can see that there is thinning of the retinal nerve cell layer. And this has been shown across multiple publications and in multiple groups, so that it may turn out that Alzheimer's has a unique retinal fingerprint, which can be recognized. Carol has moved on because back to Hong Kong, where we've applied artificial intelligence to show that these images collected from thousands of patients can have a very high predictive value for Alzheimer's disease and actually biomarker-proven Alzheimer's disease. We continue to work on OCT with Jacqueline Chua and Leopold at SERI. And again, we've been able to show that using deep learning techniques, you can use OCT to predict for Alzheimer's disease. So I think that retinal imaging is hopefully going to be very useful. We're going to start up a grant quite soon with colleagues at NUS to go and bring this kind of technology to the clinic and to the community to see whether we can use it as a screening tool. But I'm a clinician, so these are the questions that patients and families want to know. They want to know, am I at risk of having a disease? Am I at risk of aging? If I have a diagnosis, what it is? What stage is the disease? How fast will it get worse or not? What treatments should I use? And then when the treatment is started, is it working? Should I adjust my dose? And can the treatment be stopped? Now, of course, those of you who are oncologists will realize that many of these questions have been solved for oncology. And the reason is that oncology has a lot of biomarkers. And in the Alzheimer's disease and the dementia world, we didn't have biomarkers, reliable biomarkers, until recently. And this has really transformed the field. So we are now in a position that we can redefine how the clinical pathway for Alzheimer's disease. In the past, it was very reactive. You waited for patients to have symptoms, then you tried your best to go and sort of decide what was causing the symptoms, and then you didn't have very good treatments for it. But now, we realize that with especially blood-based biomarkers, we can improve management throughout the entire course of Alzheimer's disease. And we'll go through it in a little bit more detail in the next couple of minutes. So why blood biomarkers? Mainly because the established, validated biomarkers for Alzheimer's disease have got their drawbacks. The main biomarker that has been used for many clinical trials, etc., is PET. Now, amyloid PET is not very accessible because you need a cyclotron, you need a PET camera, you need PET chemists, and worst of all it's really quite expensive. The cost in Singapore is about $5,000 a scan, and maybe more if you're the only person going for the scan. Okay, so maybe to our pharma people, $5,000, that doesn't sound very much, but for most patients, it's a barrier. The other alternative, which is cheaper, is accessing cerebral spinal fluid by doing a lumbar puncture. As a neurologist, I don't understand why people don't like lumbar punctures. I mean, what could go wrong? You know, you have a nice neurologist like me coming behind you with a mask and all sort of dressed up with a long needle and telling you, don't worry, it won't hurt. Brian, you would go for lumbar punctures, right?
Every week.
Every week, that's right. So it turns out worldwide, only people like Brian and Swedish people like lumbar punctures. Most other people don't. So it's viewed as expensive, it's viewed as dangerous, etc. So having blood biomarkers turns out to be a real advantage because all of us are used to sort of having blood tests. Now the problem, of course, is that until the last 5 years, blood tests for Alzheimer's disease was a wasteland. And the major reason for that is that the amount of pathological proteins detectable in the blood is about 100 times or 1,000 times less than what you can detect in the CSF. So until the advent of really sensitive technologies, it was not possible to detect these amounts reliably. But now we have many different pathologies, and Joyce and Mitchell have reviewed this, and we have produced results to show that actually they are very good at predicting for amyloid in the brain. With AUCs in this particular study using an earlier form of phosphorylated tau approaching 0.9. And you can use ratios to increase this. But 0.9 isn't good enough because an AUC of 0.9 doesn't give you sensitivity and specificities above 90%. And I think that for most of us, looking at a test, you really want it to perform that well. So this is the recommendation by the Global CEO Initiative. I think it's a terrible name, but this is the standard that has been set. And it seemed to be a hurdle too high until last year, when colleagues, Nick Ashton and colleagues, were able to show that using a new assay to another a molecular form of phosphorylated tau, p-tau217, you could detect amyloid and tau in the brain really, really accurately. Sorry for the dense slides, but you could show it that this worked in multiple cohorts. And importantly, the result was as good as CSF. And we've just published this paper showing that it works in Asians as well. And in particular, it works in Asians who have concomitant cerebrovascular disease. The AUCs are now above close to 0.95, which is about as good as you can get. So that means that we can do trials better, clinical trials better, because if you have good diagnostics, you can choose the right patients. And the MACC has taken part or contributed to many industry-sponsored as well as academic industry partnership trials. And I'm just going to focus on a few. A trial which we began a few years ago was based on the FINGER trial. You heard about FINGER earlier, where you could show with multiple lifestyle interventions, you could delay cognitive decline. But of course, most people are very skeptical. You know, you can do it in Finland. Finland's like Estonia. Ethnically homogeneous, with a peculiar tendency to want to go and sort of go to saunas and roll about in the snow. And in general, people felt that Singaporeans were different. We were far too fussy about our food. You know, these people in Finland, all they do is drink vodka and eat pickled fish. But over visits to Finland, we discovered that the new Nordic diet was quite palatable. So you see a picture of me visiting Finland, and they brought me to the canteen, and I said, well, what's the new Nordic diet? And they brought me down, and the dish of the day was fish curry. So we thought maybe we can do the trial in Singapore. And we did the Singer pilot trial. And Brian is featured here because you gave us the money. Thank you very much. You've probably forgotten you've given us the money, Brian. But it was possible to do this trial, and we were able to show that it's feasible to do lifestyle interventions and exercise and all these things in Singapore. I'm glad to say that then we got money from the NMRC to randomize over 1,200 people to either self-guided lifestyle management or structured lifestyle management, to eat better, exercise more, control vascular risk factors, and do some cognitive training. So that's the money and the people. Okay. And the good news is that we fully randomized the trial 2 years ago, and we're completing the 2-year follow-up end of this year. There will be a result later next year, and we are confident that it will be hopefully positive. And on top of that, we have done a lot of blood biomarker work, so we'll be able to try and understand the underlying mechanisms for why there may be improved cognition. What about targeted treatment? So in the primary care, there is difficulty right now because people just don't have time to assess patients. But what we think is that in the future, accessible and low-cost tools for screening, such as digital assessments or blood biomarkers, will change this. There's evidence to show that blood biomarkers in Sweden has increased the confidence of primary healthcare practitioners. But what about in Singapore? So we've done a pilot study where we've implemented a digitized version of the quick dementia rating scale, and it's very acceptable to our local population. They prefer this over blood testing and MRI. So we have now gotten funding to do both the blood biomarkers and the digitized tests in the community, in the active aging centers, to see what is the prevalence of disease and how we can improve referral patterns into specialized centers. And finally, treatment. So now that we can make diagnosis and we can do biological diagnosis of Alzheimer's disease, we can actually try and use these biomarkers in the clinic to decide how certain we are about diagnosis and change management. So for the last year and a half, we have provided blood biomarkers for everybody that comes to the NUS Medical Clinic. The uptake is very high. The preliminary analysis shows that we don't change diagnosis that often because actually I think clinicians are not too bad, but our confidence increases, and this leads to changes in management in two directions. For the patients who have early dementia, we now can confirm they have Alzheimer's disease, and there are now treatments for early Alzheimer's disease. But also for the people who have subjective cognitive complaints or mild cognitive impairment, if they turn out not to have Alzheimer's disease, not to have any structural lesions, it's actually okay to discharge them. And in fact, that is really the big revolution in most memory clinics, because it's the people that you can't discharge that always proves to be an issue. So much so, and I think that this is really going to hit the big time because the FDA has approved the first blood biomarker available for Alzheimer's disease. And I think it's a Japanese company, it's Fujiri Bio. So this is approved, and many other companies are coming along. So all of you will soon be offered the opportunity of testing whether you have Alzheimer's disease. But it may not be such a great idea because there are obviously, as we discussed in the ethics sections, many good reasons why you shouldn't get tested. If you don't have symptoms, please don't test yourself. If you are too severely affected, it won't change anything, don't test yourself. If you don't understand how to interpret the test, please don't let any Tom, Dick, and Harry test you. And please do not respond to internet requests to go and test your genetics or your blood biomarkers. But most importantly, these advances in diagnostics has given us the opportunity to intervene earlier. And I think there's good evidence to show that this is the way forward. So many of you will know that treatment of Alzheimer's disease has been a translational abyss. Many, many failures. And there are lots of reasons. It's a different lecture to go through them. But I just want to emphasize that we've learned from these mistakes, and we now have good treatments. And that's because we've realized that not only do you have to identify the right target, you have the right drug, and you have to treat at the right time. Too late, no point. Too early, you can never get an outcome. You just have to choose the right stage. So I'm just giving one example. This is a drug developed by Eisai and Biogen called lecanemab, which is a monoclonal antibody targeted at protofibrils, which are a toxic form of amyloid. And earlier trials showed the right dose, which turns out to be 10 milligrams twice a month, based on the PK and the effect. And they went into a large phase 3 trial, which Singapore and many other Asian countries took part in, which showed that you could virtually eliminate amyloid in most patients. And importantly, it also showed a significant slowing of the decline in Alzheimer's disease. So this is the first drug which has been approved fully by the FDA to delay the progression of early Alzheimer's disease. And as you can see, it was not just approved by the FDA, but also in China, Japan, in Singapore, and many other countries around the world. Initially, a lot of opposition, but I think people are coming around now, even the Canadians and Australians. The good news is that after the trial ended, there was an open label extension, and the effect size seems to increase over time. So the amount of change was only 0.5, thank you, and it's now increased to about 2 points over 4 years. So the effect is persistent. Furthermore, subgroup analysis suggests that if you are treated at an early stage of disease, so these are people who are amyloid positive but tau negative, you can basically stop the disease. These people do not progress, and in fact, many of them actually get better on treatment, which is very promising. So this is the last slide, just to say that for Alzheimer's disease and dementia, precision medicine has arrived. We can use blood biomarkers and other diagnostic tools with great accuracy. And there are now disease-modifying treatments. They have their drawbacks, they're costly, but I think that this opens the door for more and better treatments. Thank you very much.
Thank you, Christopher. So time for questions.
Hi, Chris. Beautiful and very comprehensive. Coming again from the preclinical side and doing more metabolic work, I'm wondering what's your take on, people are working on blood biomarkers for Alzheimer's disease and dementia, like looking at things like mitochondrial DNA copy number, which they claim it's changing according even to staging of the disease, or even some metabolites that are present in circulation. So what's your take or feeling about that? Or do you think there's something that we can add on top of these current biomarkers?
Oh, absolutely. I mean, just because we've succeeded in an anti-amyloid trial is clearly not the end of the story. We're not stopping the disease. It's still continuing. So there probably is other pathophysiology going on. And of course, a top candidate would be neuroinflammation. Another candidate would be tau. So now trials are going in preparation to add additional treatments. But I think the first step is to get rid of amyloid. As for other possible pathways, I think that we really should reinvestigate using advanced omic platforms what is really going on in our patients. And one of the problems of previous studies is that we didn't use biomarkers for Alzheimer's disease. We used clinical diagnosis, and it turns out that between 30 to 50% of people you think of Alzheimer's disease don't have amyloid. So your metabolomics, your proteomics are all just going to be nonsensical. Now, I'm glad to say that this is happening. So we have a new generation of young investigators who are using proteomics. So Ming-An has used Olink to go and sort of show that we can predict using our cohort and also replicate in the ADNI cohort potential markers for a variety of pathophysiologies which can predict for incident dementia. And she's also managed to go and sort of use retinal imaging using AI to identify a retinal aging clock to show that, again, you can predict. So we are now looking into what are the mechanisms behind this aging clock and to go further with the omics.
One more question.
Thanks for the talk. So the open label, I'm here.
Oh, hi. Sorry.
The open label extension of lecanemab looks very promising. If I'm not wrong, lecanemab is administered biweekly IV. So is the extension also biweekly IV, or is it lecanemab was stopped at a certain point?
Very good question. So after the 18-month trial ended, anybody who was still on lecanemab was offered the chance to continue on treatment. Now, more recently, it's been shown that it is possible not to give it twice a month, but to just give it once a month. And also, it's been shown that it's possible to replace infusions with subcutaneous lecanemab. So the maintenance phase, or even the induction phase, may look very different in a few years' time. By contrast, the other main competitor to lecanemab is donanemab, where they had a stopping rule because there was a repeat amyloid PET scan. And if you showed that your amyloid PET scan was clear, you were cleared of amyloid, you stopped treatment. So these treatments differ.
One more.
About the finger and the singer trial, I really love the multi-domain approach. So two related questions. Why is this not more common in, for example, for cardiovascular trials? And secondly, will you look at this kind of outcome, all-cause mortality, cardiovascular or something else in the singer trial?
So to answer the second part first, yes, we are looking at other outcomes in addition to cognition. And I think that the finger trial has shown that the longer-term outcomes are also beneficial. Less hospital admissions, less deaths, etc., etc. Why don't cardiologists do multi-intervention trials? I don't know. I'm sure they do, actually, because this multi-intervention design actually came from diabetes. And it may be because cardiologists have such effective medications, they don't need lifestyle. Maybe not so patient. But I'm glad you brought out the point. I think that our experience in the cognitive field is that a single intervention is not enough. Exercise alone is not enough. Sorry, Joming, where are you? Diet alone isn't enough. Cognitive training may not be reproducible and transferable. Control of vascular risk factors, well, that hasn't been shown to be enough. But combine them all together, there seems to be a synergistic effect or an additive effect. So if there are no more questions, I will just end by saying, obviously, I've talked a lot, but but the future of the MACC doesn't lie in me. I'm going to be retiring. The future of research in Singapore belongs to young people, and I would just name a few. Incredibly, our neurosurgeons are very keen on cognitive impairment. Mervyn is working on cognitive impairment in hemorrhagic stroke, and is doing a lot of fantastic MRI work on connectomes. Arjun is taking on the challenge of surgery for Alzheimer's disease. It turns out there is an operation to improve lymphatic drainage, and we're starting on our first patients to see whether we can really show biomarker effects. And of course, I'm sorry I gave the wrong impression in the beginning. I do work with basic scientists. So David and Hao Jie, we're working together to see whether body fat produces amyloid and may cause Alzheimer's disease. So anybody with a bright idea, please come and talk to us. Thank you.
Thank you, Prof. Chen, for a brilliant presentation.